Dear friends, welcome back. In this video, I'd like to do the machine on the Vulnhub, which is Tr0ll. I will add the link into the description section below so that you can download and play the machine if you want. If you want to learn the buffer overflow attack, I think this machine is good for you, because in this video there will be a lot to take. So it will take me a bit long time to finish this machine, since I'd like to demonstrate the buffer overflow attack in detail. Before we go ahead, if you don't mind, please subscribe to my channel and leave a like below. You're greatly appreciated. So enough said, let's just get started. We can switch into the Kali Linux VM. The first thing for us to do is to discover the IP address of a target. The utility I'd like to use, as always, would be netdiscover. As you can see, I use the option of R to specify the network range to speed up this process. As you can see over here, the IP address of the target could be recognized as 118. So what do we have to do next? We need to do the port scanning to identify open port number on the target. To save time, I've already done that earlier. So for now, we just cut out the result. As you can see over here, I use the options like scene scan, the version scan, the default script scan, and then followed by the -p- to do the full range port scan, because I do not want to miss any open port number. And the last option of all is ON, to output the result into this file. ON means the normal format, although the mmap can support other types of formats. As you can see over here, the IP address has been changed from the one I did the first time. So from the mmap scanning, we can tell that the target had 3 open port number. The first one is 21, which is running FTP service or file transfer protocol, and also its version number information, although at this moment the mmap cannot make certain that it's version number. Okay, and the next one is 22, which is running SSH service and also the version information. I think this version is very old. However, besides the username enumeration, we cannot find any other workable vulnerabilities. The next one is 80, which is running HTTP service and also the version information, Apache 2. So what are we going to do next? We need to do the enumeration for the HTTP service, both manually and automatically. Let's open up our browser and put the IP address of the target into the address bar. We got the page back, so me again, now, and we need to check its source code. Here, nothing here. Try harder, author. So maybe this is the possible username. We need to keep this information onto our notebook. Okay, so this is the possible usernames. Okay, and also here has one page. We can download this page into our working directory. So which one? Yeah, this one. Save. And next, I think we can check whether this site has robots file. Yeah, it has. The user agent disallow. So maybe there's So of course we can check them one by one, but or we can use the shell script to do this. However, for me, I'd like to use the Python. Python is easier in comparison to shell in terms of the syntax. Okay, so let me show you how to do. We can first of all we can download the robots file. Sorry, the IP address of the target and the robots file. It's done, and we can cut out this file. Maybe we do not need the second one. This is the history file. Okay, so we can cut out the robots file. Make sure we have already downloaded this robots file. Next, we can launch our Python. We can import requests module. Import requests. And we can open up the robots file with read-only mode with for line in read lines. If line it starts with slash, because the first two lines are not directory. Okay, and then if it's true, and then we can URL should be, we need to join the base URL concatenate the line. Of course, we need to strip spaces, and then we can try response requests get URL. If response status code equal to 100, and then we can print out the URL. If any exception, we just pass. Okay, so I think among all of entries in the robots file, only these two entries are valid. So next, I think we can go to the browser. So this can narrow down the scope of the directories, right? So we can access loop this picture, and we can download this picture to our working directory. Later, we need to make analysis. And the next one, keep trying. We can copy. However, this is another. It looks like this is the same picture. So, of course, we can use different file name. Maybe the picture has different message inside. Okay, and the next one is don't bother. We can copy. Another picture. We can and the next one. Okay, this is it. We can copy. We should be patient when we do such immersion. Another one, we can save. Save. So it looks like the picture has same size. Okay, we can use exif2 cat Nothing there. Okay, and then maybe we can use the strings cat. Maybe we can check them one by one. Nothing there. So the second one. Okay, here I think we can look deep within this directory. Should be directory for your answer. Okay. And the next we can check another picture. Nothing there. Nothing there. All right. And also has another picture. We can use the same command to look for some weird information or interesting information rather. Nothing there. Okay, so I think we have already found another, maybe the directory, right? And we can put in here. We got this. I think this should be the word list, and we can download to our working directory on the Kali Linux. And for now, we don't know where to use this word list, right? So before we go on, for example, to do some cracking against FTP surface or SSH surface, I'd like to do more immersion with HTTP surface. Okay, so Tr0ll. I don't think we can find anything useful from the Tr0ll. Next, we can use GoBuster to do the directory immersion. Of course, I've already used the GoBuster very often, right? And extension option. Press enter. The robots file. We do not need to take a look at it again because just now we have already downloaded such a file and also retrieve the information of the entries in this robots file. All right, I don't think we can find anything else. So I'd like to interrupt it here. So how to do? Just now we have already identified the possible username, and also the author give us the word list from this directory, right? Even we can cut out this word list. Yeah, very big. I think this is very big word list, about 10,000 words in this dictionary. And as you know, very suspicious. It looks like such words is encoded in base 64. We can copy and we can use the echo base. Yeah, it's right. It's encoded. So I think before we can use this word list, we need to do the decoding first. This would be very easy. We just cut out the answer and tunnel to base 64. And then we can write to passwords dictionary. Okay. Of course, this new dictionary has the same numbers of words as the answers.txt file. So maybe next we can use Hydra to crack the password. Now we have already know the username, right? So we can copy the username. First, we want to crack the password for the FTP service. All right, we can press enter. I will come back when it's done. Okay, let's continue. I think we made a mistake. Actually, this will not work. This is another trick. In the CDF-like machines, in some case, the FTP or SSH, the password will be the same as the username. Okay, so now we can try to log in to the target via FTP, and we can put, so welcome to this one. Any loops stay for a while, and we can use the same Tr0ll as password. Not successful. So we can copy, maybe copy and paste away is the safer way. As you can see, it works. So now there is one file. We can get down such a file onto the Kali Linux, and then we can unzip this file. However, it's password protected, and then we can, this time our password list can play role. Okay, and the utility I'd like to use is fcrack zip. And if you do not know how to use fcrack zip, we can use help to display its usage. For example, we need to use this option U, and also this option we want to do the dictionary to crack. Okay, and use option the normal P to specify the password dictionary. Okay, let me show you. Fcrack zip password. As you can see, very quick. Fcrack zip is very powerful and very efficient. We can get the password, then we can unzip with this password. It's done, and then we can get out this file. It looks like this is the private key, and we can, of course, the username should be loop, because from just now we have already seen that the loop is only stay for a while, so loop would be the possible username. Also the name, the file name, the private key, the file name itself is called loop. So before we use this private key, we need to change the permission loop, and then we can SSH with I to specify the private key. Yes. However, we got this error, no mutual signature supported. So I think I've already encountered such a problem. We can, the first link can give us the way to solve this issue. We just put the O option and connect again. As you can see, we are connected. Try harder, low connection to close. Although this private key works along with this option, we can use this option to specify the accepted key types, which is SSH, RSA. However, the collection would be closed immediately. So we need to, I think this is some sort of the restrict shell. We need to escape from it. So how to do? I think I already demonstrated such a technique. For the SSH escape, we can use different ways. For example, the first way, always I will use this way. For example, we can use the T to specify the terminal type. Some case this technique can work. However, this time we cannot get what we want. And then we can try the second way. No, cannot work. And then we can try this way. We can copy. This way, utilize the shellshock vulnerability. Okay, and we can copy. I think there is one Vulnhub machine in relation to this vulnerability, and we can paste in here. I also put this information into the description below so that you can use it if you want. Of course, we need to put the single code to include this information. As you can see, it works. And now we can, we have already logged in, and we need to do some local emulation. There's some other users, and I'd like to go back. We need to get out the bash history. So maybe this machine has a lot to do with the GDB. GDB is very famous debugging to a utility. Okay, so we can note down such information. Maybe we can use the GDB. And let's go back. Go to another users. Nothing there. Go to Tr0ll. We have already downloaded this file onto our Linux. Next, we need to check the sudo. And of course, at this moment, we do not have the password for this user yet. Next, we can try to find all binaries with SUID bit. So we can use a find perm option and type. At the bottom, as you can see here, very weird. Nothing to see here. Of course, we must see this place. Okay, choose wisely, and door 1, door 2, door 3. So we can go to choose, and the 3 subdirectories. Go to door 1. So there is one binary, and so this target has GDB. It's there, and we can run this binary. We need to provide or need to specify the input before we try to exploit this binary. I'd like to take a look at the other two directories. Oh, well, executing root shell, good job, stand by. So this one doesn't allow us to specify the input, right? Not the Tr0ll1. Go to the Tr0ll3. Two minutes, harder mode, AOL. So also this one is not required to specify the input. So I think our target should be the Tr0ll1, okay? Okay, permission denied. So I think this is another trap. This binary root would be moved from for maybe every 10 minutes, every 2 minutes, whatever. And so we need to wait. Maybe we can go to the, even now we cannot do anything. So this would be very dangerous. We need to wait about 2 minutes and then we can go on our exploitation. So I think now, next, I think we need to try to check whether this binary has buffer overflow attack. As you know, the buffer is allocated space by the program and to store the strings. However, if the program doesn't validate the input and the input information, for example, some sorts of specialized strings, will overwrite or maybe I can use the word pollute, will pollute the EIP or the extended instruction pointer. EIP is very important for the buffer overflow attack. Always we need to locate EIP and try to, EIP is in the normal situation would be the memory address of the next instruction. So after we call the function and after finish executing the function, and then we'll return and then go on. So the EIP will store the memory address of the next instruction or the return address. This is the key part of the buffer overflow attack. Okay, so maybe now we can go inside the Tr0ll1. As you know, for the buffer overflow attack, there will be some steps. The first step would be spiking. We need to provide very long data to see whether this binary is vulnerable to the buffer overflow attack. And then we can do the fuzzing. And next we need to find the offset. Offset is the location of the EIP. And also next we need to, find the bat characters. We need to remove such bat characters in order to, because we want to put our shell code into and let the shell code to be executed. Okay, and after we can make buffer overflow attack, and we will put the ESP or this one is the address of the current instruction, and we'll put the EIP. So the shell code will be executed. However, if there is some bad characters in the shell code, and such bad characters will prevent our shell code from executing properly. Okay, so I think it's very important to identify the bad characters first. Then we can use the MSF Vulnhub to generate the shell code, and then we can exploit or we can make the attack against the buffer overflow vulnerability. Okay, so let's do it one by one, and we can. So next we can try to fit the long data, right? However, it's nothing there. Very weird. Go to. So I think this is the difficulty for this machine, and we can run. We need to so this time this binary has been moved to this directory. No problem. We can root, and we can, for example, we can provide of course the print, the Python is on the target. Okay, Python 2 is there, and then we can fit very long data, for example, like Python print. Maybe I can use like 100, no error. And next I can add to 500. We got the error. Also the 10,000, we get this segmentation fault. If you see this error, it means that maybe this binary or this executable has vulnerability of the buffer overflow, or the program didn't or doesn't do the validation of the input. Okay, so what are we going to do next? We need to find the EIP, and how to do. We can use the, or maybe we can use the maybe we can use the script or the code or utility to create the specific or particular strings, and this string has particular pattern, and this can help us to locate the EIP. Okay, so how to do? And we can open up a new tab. Let me zoom in the terminal. We can use the USR share metasploit framework tools, exploit pattern create, and I want to create 1,000 characters. As you can see, it's here. We can copy, and then we can launch our GDB and the root, and we can, of course, we can fit print and sorry, not this one, print as you can see, we got the error. So next, I think we can then, this is the, I think this should be the address of the EIP, and we can use IR to display, this one. And also, if you want, you can use we can display the data of this address. As you can see, this is out of bounds because the EIP has been override by our strings. And this strings is not actually memory address. So if you want to print out the data with this memory address, give us the error out of bounds. Great. So next, I think we need to locate the we need to get the offset. I mean the location of this of the EIP, or the starting of the EIP. And next we can use the Metasploit tool, Metasploit tools, exploit pattern offset, and we can copy this address. Okay, so the exact match of the offset is 268. So let me confirm. We can run, for example, we can run and Python print and we can put 4 bytes of B, and the B will be put into the, or overwrite B into the EIP. Okay, originally the EIP should be the memory address of the next instruction. So I think I've already explained it clearly. And 4, and then we can put, for example, like the capital C, we can put as you can see now. If we display the, as you can see over here, ESP. So EIP, 42, this is the hex of the capital B. So you know what I mean, right? So it means that we have already successfully overwrite or overflowed to the EIP. And so what do we have to do next? We have already found the offset, and the next we need to find the better characters. So how to do? We need to, I've already opened up this GitHub, and I also added the link into the description section below. And this script can help us to generate the characters. Okay, so go to the and we can run this binary. As you can see, we got these strings, or this data, sorry. And now we need to fit the purposefully built data. We can Python and print, and the first should be filled with our A, and then B, and then we can put the sequence. If the specific data cannot be displayed, and then this will tell us this should be the bad characters. Okay. And next we need to print out the the data after, for example, the 100 bytes after this address. So let me show you. We can use this X here means hex, B means byte, and we can copy. As you can see, the 1 is correctly displayed. 2, 3, 4, 5, 6, 7, 8. However, the 9, originally the line should be there, right? So it means that this should be the bad character. Hopefully I have already explained it clearly. We can copy and put in here. This should be the bad character. So we need to repeat this step, and we can, for example, we can copy, and we need to, maybe I can open up, we need to remove this bad character, and then we need to copy and run the same process again to identify the next bad character. We can use the R print, the Python print. This should be offset, and we put B into the EIP, and then we can put the new sequence of data, and then we can use the so we can X followed by this address, and to see which character is not printed. So now we need to check. So next should be 0A. I think there'll be something wrong. So I think this one is not displayed correctly. So I think we need to copy and put in here. This is the second bad character. So we need to remove this bad character and then repeat this process again. So we can run print, Python print four bytes of B into the EIP, and then we can put a new sequence of data, and then we can use the same command to see which character is not displayed as it should be. Okay, so the B, C, D, E, F, 1F. We must be very careful. 1F. Here, as you can see, I think there is some problem. 1F should be this one. So maybe this is another bad character. We can copy and put in here. And then we need to remove this bad character. And then we need to copy the new data and run it again. Print. We must be very careful. And put new strings. And then we can followed by this one. If all characters can be printed out as it should be, as they should be, and then we have already found all bad characters. As you can see now, I think we have already found all characters, okay? All bad characters. So next, I think we need to generate the shellcode. Of course, another bad character is 00. 00 means the space, of course, and we can copy. And next, we need to use the MSF Vulnhub. MS Vulnhub. And with the Linux, and as we know, the architecture is XEC, and also the format is Python. CMD is the shell, and next we can use the B option to specify the bad characters, what we have already found earlier. Okay, so we can copy these bad characters, and also we can specify the architecture. This is optional, and the platform is Linux. As you can see here, we can copy. This should be the shell code, and we can put it in here. We can remove must be very, very careful. Okay, so this should be the shell code. So how to do? We can copy, and I think we can exit the GDB, and the next. So now the binary has moved again. Doesn't matter. And then we can run, and then we can Python. There should be print offset, and then should be put. Of course, this time, we need to reverse the address. Not this one. We should reverse. Yeah, this address we can copy. Means that this should be like this one. X FA X FF X BF. Okay, so now we can put, so this, so the ESP means the address for the current instruction, and followed by the shellcode. So the shellcode will be executed. We will put this address into the EIP. Okay, so let me show you. We can put in here. This should be 4 bytes. And then of course, we also need to put the non-operation. For example, we can maybe 100, and then followed by the shellcode. We can copy. However, we got the illegal instruction. So maybe we can increase the length of the not this one. We can copy and we can use notebook. For example, we can increase to maybe 300. Segmentation fault, and we can increase to 500. And we can increase to 1000. Segmentation. So there'll be some error. Should work. Permission denied. I think I need to wait about 2 minutes. I think the problem is caused by my careless mistake. I put this, this is wrong, and so I have already corrected the error, and now let's try it again. We can maybe 500, and we can copy. Python print offset, and then we just because this should be the whole command. As you can see, it works, and now we have already get our privilege escalated, and we can get out the final flag. So that's pretty much it. I hope you can enjoy this video. If you like it, please subscribe to my channel, and if you want, you also can become the member of this channel. So see you in the next time.